Hi everyone, this is Emily again, and today we're going to be going over the product rule and quotient rule for taking derivatives. So basically, you're going to be using these whenever you have two functions that are being multiplied together or two functions that are being divided. Okay, so first, let's just go over the product rule formula, and I'm going to go through an example so you guys can see how it works. So basically, if you have an overall function that is equal to two individual functions being multiplied together, then the formula for the derivative of that is going to be the derivative of one of the functions times the original function of the other, plus the derivative of the second function multiplied by the original first function. And it kind of might be confusing at first, but it gets easier with practice. So the example I have here is we have 10x cubed minus 14x plus 7, and that function is being multiplied by 6x squared plus 15x minus 12. Okay, so basically we want to define this first one as our f of x and the second one as our g of x. Okay, so first let's find the derivative of f of x. So to do that, we're going to be doing the power rule. So we're going to be bringing the exponent down and multiplying and then subtracting 1. So if we do that, we get 3 times 10 is 30, and we subtract 1 to get a 2. And then over here, we are left with a negative 14. And then plus 7 is a 0. Okay, and then next we're going to find the derivative of our second function. If we do that, also using the power rule, we will get 12x plus 15. And if you guys have any confusion with the power rule, feel free to see my video on that as well. Alrighty, so then moving on, we're actually going to put these into the formula for the product rule. So we basically have our f prime of x, which we found, multiplied by the original function of our g, plus the derivative of the g, which we found, multiplied by our original function of f. And that's it. That's the answer, and it's really easy. You can do some simplifying and multiplying here and adding your like terms, but for the overall process, this is the answer. Alrighty, so next I'm going to go through another example of the product rule, and I have the formula here in case you guys need it. So basically, we have an overall function f of x equals x to the 10th multiplied by some function h of x. We are given that h of negative 1 equals 3, and the derivative at negative 1 equals 6. And we want to know f prime of negative 1. Okay, so there's a lot of mathy kind of lingo going on here, and I think it kind of scares some students, but really just want to break down what we need to know and what we already know. So we need to know what the two original functions are, right? And we need to know what the derivatives of the two original functions are. And in this case, it's at negative 1. And we are already given a lot of information for that, right? So let's first write down what we know. We know that h of negative 1 is 3, and we know that h prime of negative 1 is 6. So we already have two components of what we need to know, right? So the only other thing we need to know is, in this case, our first function and the derivative of our first function at negative 1. So let's calculate the rest of what we need to know. G of x is equal to x of 10, therefore g of negative 1 is 1. G prime of x is equal to 10x to the 9th, also using the power rule here, and plugging in negative 1, we get negative 10. Okay, so now we have all four components of what we need to know in order to calculate the derivative at negative 1, right? So then doing that, we're going to plug in everything that we know. We have negative 10 times 3. And here you can see we have our g prime times our h plus our h prime times our g. And if you simplify this, we have negative 30 plus 6, and it's negative 24. So this is our answer. F prime of negative 1 is negative 24. So if you have questions like this one, just make sure to break it down and figure out what you know and what you need to know, solve for what you need to know, and then plug it into your product rule equation, and it's actually pretty simple. Alrighty, so next we're going to be moving on to the quotient rule. Oh, ignore this that I have down there. We have a quotient rule formula here, and I'm going to go through an example. So basically, you're going to be using the quotient rule whenever you have two functions that are being divided. In this case, my example, I have 2x cubed being divided by 6x minus 3. And the formula here is almost identical to the product rule formula, except we have a subtraction here, and then we are also going to be dividing by our original g function squared. Okay, so let's go through what that would look like. Let's first find our f prime. So if our f is 2x cubed, our f prime is going to be 6x squared. Okay. And next we want to calculate our g prime. So our g prime is going to be the derivative of g, which is 6x minus 3, which is going to be 6. Okay, so next we just want to plug everything we know into the quotient rule formula. And this is what we get. So we have our original function, g multiplied by our f prime, subtracting g prime multiplied by our original function f, and that's all being divided by our original function g squared. And there we go. Like I said, we can simplify this. We can go through it, make it look a little bit better. But for the purpose of this problem, this is the answer. And most of your homework websites will accept the unsimplified answer. Alrighty? Alrighty, and then lastly, I just want to go through one more example with the quotient rule. And again, I have the formula up here for you guys in case you need it. So if we have a function x divided by x plus 6, we want to find the values of x where the derivative is equal to 5. Okay, so we first need to find what the derivative is, and then set it equal to 5 and solve for x. Right, so it's pretty simple. So let's first find the derivative. So let's first find our f prime and our g prime, because those are going to be needed for the quotient rule formula. All right, so our f prime is equal to 1, and our g prime is also equal to 1. So it's a pretty simple plug and chug here. So now we're going to plug it into the quotient rule formula. So we have our f prime times g minus our g prime times f, and that's all being divided by our g squared. All right, and if we simplify this a little bit, we can actually FOIL out this denominator. So the x plus 6 squared, if we FOIL that, we get x squared plus 12x plus 36. And also simplifying this numerator here, we get x minus x will give us just 6. And then lastly, we want to set that equal to 5 and solve. Okay, so we're going to multiply this entire quadratic over to both sides of our equation. So we're going to end up having 5 times this, and if simplified is going to be 5x squared plus 60x plus 180. And then we want to divide by 6, and you get this. Oh, not dividing by 6. Oh my goodness. So sorry, guys. We're not dividing by 6. We're going to subtract 6 and get 174. And then now we have a pretty simple quadratic here that we can either factor, or you can plug it into the quadratic formula, or you can even graph it if you're allowed to do that in your class. But here I think I do the quadratic formula. So you can see I have it plugged in here. We have our negative b plus or minus our b squared minus 4ac, or I have it written 4ca, but multiplication is commutative, so it doesn't matter. And then we're dividing by our 2a. And if we simplify this, our answers are negative 6 plus the square root of 30 over 5 and negative 6 minus the square root of 30 over 5. Okay, so overall, it's pretty easy. These are just going to be 2 new methods for taking derivatives, and you have to follow these methods if you have 2 functions that are being multiplied or 2 functions that are being divided, unless you can rewrite them another way and make it easier to do the derivative another way. But as far as multiplying two functions or dividing 2 functions, these are going to be your go-to methods. And as always, guys, if you guys have any other math questions, feel free to check out my other videos or any of the other videos on the tutoring modules. Bye.